you want?
I just need a TI launchpad.
Can't you see I'm busy here?
Don't be held hostage by the board order. Go to digikey.com to find thousands of boards in stock, all ready for immediate shipment.
Hey everyone, welcome to the August edition of Make Live. My name is Tyler Weingartner, and today I am happy to be joined by
Paloma Fotley.
And Paloma, what do you do? What kind of things do you do?
I do a lot of things. I have a degree in robotics engineering, which means that I love doing everything a lot. So programming, fabrication, working with embedded systems, all that stuff. So I'm also possibly known by the people on the Make YouTube channel or the Facebook page as the person who hosted Maker Camp for several years and have been in some very interesting YouTube videos. So part of the community.
Yes, longtime friend of the site and the magazine and of me, I'm happy to say. But again, welcome to Make Live. This is one of our Skillbuilder editions where we're going to be spending all of our time talking about this little guy, which is the ESP8266, a tiny little microcontroller that lets you add Wi-Fi to your projects. And of course, we couldn't do this series without our good friends at DigiKey. They make this series possible. And if you're not familiar with who DigiKey is, they're an electronics distributor based here in the US. Any of the components that we are working with today, you can order from them directly. You can order them fast. And sometimes you can even order them in an afternoon, and they can be on your doorstep the next day. They always ship on the same business day that you made your order, as long as they have it in stock. And they're awesome to work with. You can buy anything like any of these components that we are going to be using today, all the way down to discrete components like resistors and transistors. And anything you need to build your next electronics project, they will sell you. And they will get it to you very quickly. And we're lucky to be working with them. But anyways, today, as I mentioned, we are doing one of our Skillbuilder series. So we're not actually going to be building a project today, but talking a lot about these sort of technologies that you use in projects. And this little guy came out, that ESP8266. Let me pull up my camera here so we can get a good look at the guy, the little chip there.
Yeah, we have some people saying that they would love to use Wi-Fi in their projects, and this is a really great way to do it. It's cost effective, it can be used standalone, but also in conjunction with other boards, like somebody said, using a Raspberry Pi with Linux. You know, you can add this to projects, and it's just a really great thing to have in your arsenal as something you know how to use and something you know how to work with. Yeah.
So this is the ESP8266. It just contains these 8 I/O pins. Well, they're not all I/O. In fact, only 2 of these are I/O. There's power, ground, and a couple of TX and RX and a couple other things there. There's of course the Wi-Fi antenna that you see right there, and the microcontroller chip. And people were starting to use these just to add Wi-Fi to existing projects. In fact, this thing became, because it's so cheap and so ubiquitous, I think it still only sells for around $2 a piece. I'm sure if you're buying them in bulk, you would get them for even less than that. So this is powering all sorts of things like the Amazon Dash button and lots of other relatively cheap Wi-Fi enabled devices. But eventually it was hacked to basically be programmed directly like a microcontroller. And then that allowed things like some other boards to come along, because the little ESP8266 is great, but it's limited as a microcontroller by itself. Because it only has 2 GPIO pins. There's a couple other limitations. We'll get into those a little bit once we start throwing some code at this guy in a little bit. But you also get boards like this, which is this is the Node MCU. You can see it has the ESP8266, but it's also a full-fledged microcontroller, so you can get a lot more capability out of this guy. And then, of course, there is my favorite of these types of boards. This is the Feather Huzzah. I've used this in a ton of different projects. I've used it in a ton of different projects in this series, and we're going to be revisiting a couple of those as we go through the content today. But also, while we're just starting to talk about what all this is, if you have any questions for us, be sure to drop those into the chat down below, whether you're watching this on YouTube or on Facebook, and we will do our best to answer them. We try to be experts at this stuff, but mostly we're just kind of figuring it out as we go along too. We've done a little bit of research.
Yeah. And if you see me looking over here, it's because I'm reading your messages and figuring out what to ask Tyler or to answer myself. So I'm not just interested in what's going on over here.
All right. So as I mentioned, there are a couple of limitations of working with the ESP8266. And let's I'm going to pull this camera back a little bit because we need a little bit more room now that we're not just looking at the board itself. Get our focus going there.
And so Kirby Wood says, what does it do with a bunch of question marks? So when you say something like an IoT Wi-Fi enabled board, like what does that do for your projects?
It can do a lot of different things, and I mean, it lets your microcontroller speak to the internet or allows the internet to speak to your microcontroller. So you can do a bunch of different things there. Like if you wanted to, you could do everything like, and one of the things I'm still trying to chase is to create a fake, or create my own dash button. I wanted to do that because at one point I was buying so many of these, that Feather Huzzah, that Amazon created a dash button, but just a virtual dash button, a button that I could poke at on my computer screen that I would immediately order one of these. And I want a real one, because I've ordered maybe like 30 of these over my time spending money on Amazon. But as far as I can tell, I haven't found a way to directly access buying something through their API. But you can do other things like, say, push a button, and then that might create an event. You can use a couple of different technologies. We're going to use that, like push a button, and maybe that might reserve a meeting room at your workplace. Or you can have a little thing on your on your meeting room that says a little X or an O saying, hey, this meeting room is booked, it's been occupied. And it can read your company's Google Calendar to make that determination. In this case, this is, we're going to demonstrate this later, but this is a sign I had on top of our live streaming camera at Maker Faire this year. And this is using if this then that to track a couple of Twitter hashtags and a couple of Twitter accounts. And it normally has a nice like glowing a NeoPixel display that's lit up through the sign, and then when it detects one of those hashtags, it flashes bright colors everywhere. So that's one of the examples of a way that the internet can talk to it. So basically, all kinds of interactions between internet and your microcontroller hardware, whether you want to collect data from something, like if you had a temperature sensor that was attached to your microcontroller, you can use it to connect to the internet. And then use a data management system like Adafruit IO or MQTT, which actually Adafruit IO is a broker for MQTT to track and store that data. And then you can manage it later using any number of tools you wish, like dumping it into a spreadsheet or however you want to use that data. So that's just a couple of examples of what making internet things, making your own Internet of Things devices can do. So it's really pretty open-ended.
Very cool. And somebody was asking, you mentioned that it was $2 for the smaller board to be able to buy that from a place like DigiKey. How much would all of the other boards range from in terms of getting just the ESP8266 all the way up to something like a Feather?
That is an excellent question. So I have this. The ESP8266 is not that useful on its own for programming, because most of the time you're used to programming it through a USB interface. So the ESP8266 is just $2. You'll also need this guy, which is, I think you can buy these normally for like $3 or $3.50. So this is just a board that lets you plug in your ESP into your computer so you can program it. And it does a couple other things that that make life a little bit easier. Moving on to some of the other boards we're looking at today. This is actually let's look at this one next. The Node MCU board is actually quite inexpensive while still having a ton of GPIO pins. The board footprint is actually fairly large by comparison, but this one is, I think you can normally find this for like $10 or $12. Still pretty affordable for a full-fledged microcontroller that you can also add Wi-Fi stuff to. And then there's the other one we're looking at today. This is the Faire well, this is the ESP12, which is a slightly different flavor, the ESP microcontroller. This one you can usually find for about $20. And then what's coming out now and becoming more popular, I haven't worked with it a ton, so we're not going to be talking about it today, is the Faire ESP32, which, if I'm not mistaken, does not only Wi-Fi enabled wireless connectivity, but also Bluetooth. It is a little bit more expensive. I think it sells for like $25 or $30. But as I mentioned, I haven't had a ton of experience building projects with it today, so we are not actually going to be talking about that yet today.
But good information to have.
Yes. Okay. But back to the base ESP8266 module. One of the important things to know about this board is that it has a voltage regulator on it, but not one with a very broad range. It will only accept from 3 to 3.6 volts. And that's 3.6 volts is really important because that means that you can't even power this off of a LiPo battery without doing something to control that voltage a little bit more. So that's part of what this board is doing, is not only creating the USB connection, but also bringing the voltage down to something it can manage. But the nice thing about that is you can also power the ESP off of a pair of alkaline AA batteries, and you can do that pretty well. I wouldn't try that with the rechargeable AA batteries because those only output 1.2 volts, so you will be not providing enough voltage. The other thing that is important about this board, in particular when you're using it to program your ESP8266, is that to put it into programming mode, you need to ground GPIO 0, which is the pin that this yellow wire is connected to. But then if you want to use this to just power your board and run it, you need to remove that grounded connection. So that's why I've created this little thing. It's just a little micro switch that's just connecting those two pins. So when it is in switch over here, where it's closer to the yellow wire, then it's ready to program. And let's do that now. And then you can switch it over to the other side, and then it will run your code.
And I know a few people were asking about how difficult it is to program something like this in Arduino. So do you have to do a lot of setup, or is there a lot of example code already out there for you?
There is a ton of example code. I mean, right now, one of the first bits of code that I'm going to be using, it's as complicated really as any other microcontroller. So if you've done even the basics, and we're going to be starting with the most basic of sketches, the blink sketch. There's a little blue LED on here that normally is also reserved for saying when the Wi-Fi is transmitting or receiving. Mm-hmm. We're going to make that blink. It's really simple, but it's a start.
It's a good start.
And it's proof of the concept that you can actually program this like a microcontroller. The only thing you really need to do for your Arduino IDE setup is, and there's tons of tutorials for this, you need to go get this JSON file, if you haven't already, for the general ESP8266 family of boards. Plug that into your Arduino IDE, and then just download the boards libraries, and then it should detect it, and you should be off and running. And then it's as simple as any other microcontroller you've ever programmed through that interface. And let's take a look at a bit of that. So first things first, we're going to plug this guy into our computer. So get the camera a little bit closer to it so you can see it while it's being programmed. And then I have this. My code is very tiny right now. I apologize for that. I'll adjust that in just a moment. Make it so it's easier to read for everybody out there. All right. So this is just, in particular, we're telling it the LED pin is pin 1. That will actually blink the onboard LED that I was mentioning earlier. And of course, then we get to the actual code of the blinking, which is just stay on for 1,000 milliseconds. Let's change it to 500. And then let's have it be off for 250, just so we can prove that we did something here. Go under Tools, check that our board is this generic ESP8266 module. Everything else here should be good. I mean, there's a ton of different options here as far as like flashing mode and things like that. You shouldn't really need to mess with that stuff too much. And probably do need to double check our port. Which you need to tell it it's on the USB serial connection. And it says it's compiling, which is always a good sign. And now it's slowly uploading, which we can see. If you take a look at this little blue LED right there.
Yay, there we go.
Little bit of blinky feedback. Maybe
We did something.
But, and that's, it's saying it's receiving the code. And then in the moment, it will then change to our actual blink program. It's 72% uploaded. And that's our blink sketch. You can probably see it right now. You can see it's staying on for half a second, then off for a quarter second. And okay, so we've managed to actually program the little ESP8266 board like it's a microcontroller with the most boring sketch ever created. Let's try and do something a little bit more fun. If you followed any of the stuff I've done on this stream or on the Make Magazine channel, you'll know that one of my favorite IoT apps is an app called Blink. And I need to, and it is a app that runs on your phone and lets you control microcontrollers from your mobile phone, which is really fun. So what if we could turn that LED on and off from our phone instead of it just doing that all its own? And then we know that it's actually happening from the internet. So I need to get a auth code for my email, which I'm not going to show you, but I need to jump over to my email and get that authorization code.
So some other benefits while we're waiting for him to authorize of the ESP8266, which, by the way, the whole board is not the ESP8266 if you were confused about that. There's a little tiny square chip on each of these boards that is itself the ESP8266. And a lot of reasons why people love this standalone chip is that it is really low power. It actually has an on mode and a sleep mode and then a deep sleep mode. So that way you could have this running on its own off of a battery for a very long time without needing to charge the battery or replace the battery and still have it be able to talk to your Wi-Fi. So I've seen some people actually use this for creating their own security systems at home, being able to tell when their garage door is open and have it send an update to their phone or something like that. And you don't need to change the batteries that often. So it's really nice to have that. Let's see what else people are talking about. And for anybody else who was wondering where HEP is, she is now working on with a company that 2D prints 3D printers. So she's very busy doing that today.
Yeah, she unfortunately has moved on.
Not too far though, because she's
No.
in the comments on this video.
All right. Oh, and I still need to tell it. Oh wait, no, that setup is all happens on. So I'm gonna upload this new code to our ESP8266, and the rest of the setup, I believe, should happen on my telephone.
So Cole was asking if we can describe how to set up an ESP for low power usage. So from what I know about that, there's actually pins on the, as, who said it here? Bill DeBailey said that it's called an IC, an integrated circuit. So there's actually pins on there that allow you to activate or deactivate sleep mode. Depends on which board you have on how to be able to use that. But if you're not familiar with reading data sheets, this is a really great time to look through. Just type in the board that you're using or the IC that you're using and then data sheet, and you'll find a really great file that talks about how to use that specific board. And getting comfortable reading those is a really great skill to have. So when I was looking up the ESP8266 to brush up on some of my knowledge, I found that there are specific pins that you need to enable, but if your board won't, you know, some boards have the pins on the that you can actually interface with to let you access the IC, and some of them do that for you with programming.
Yeah. Unfortunately, my comfortability with reading data sheets still has a long ways to go.
We'll get you there.
Yeah. Reading data sheets on things like switches and relays, I'm okay there. But actual integrated circuits,
They're long.
Yeah. I mean, I also have no formal electronics engineering knowledge, so
But you're getting there.
I just poke at things until maybe the smoke comes out.
Yeah.
Okay.
It's a good way to learn.
So we now we can see we have our light. It's solid blue. That's not very exciting. And so try and get my phone. Where's the best place for my phone? That'll be an okay place for my phone once I get everything focused. Okay. I'm going to stop this sketch, and then we can go into the settings for this button. So here you can tell it what GPIO pin you want it to use. In this case, we want it to be GPIO 1, so that's the one currently selected. And you can have a function like a push button or a switch, and then you can also set whether you want it, the down position to be on or off. But anyhow, once we hit play on it, then you can see I'm tapping this button, and it is making the light go on and off. Get a little bit closer there. Now, okay, this is still a pretty simple interaction, but you can do a whole lot here once you can do things like control, internet or hardware devices from your telephone. That's how I ended up developing the internet. My smartphone controlled garage door opener. Is that instead of turning on an LED, it opens a switch on a device called a component called an opto-isolator. And then that connects the connection to the garage door and opens it. And then it has a couple other things where it has a read switch, which is a magnetic switch that is normally used to determine if doors or windows are open. So I also get a little notification, or I have a little display in the app that says whether the door is open or not. And then it will also send a notification to my phone if the door has been open for longer than 5 minutes or so. So a couple different options for what you can do with this software. and that's why I like it a lot. You can also create a confetti cannon and let the internet control it. Not that that's ever happened on this stream.
No.
So that's just a quick primer on how to program just the individual ESP8266. That might be practical knowledge to you if you want something really cheap and really lightweight and you don't need a ton of GPIO and you don't want to spend a whole lot of money on it. But more than likely you're going to be using one of these other devices like the Node MCU and or the Feather Huzzah. So let's take a look at a couple of projects. Some of these might be familiar to you if you've been watching this broadcasting series for a while. Some of them might be entirely new to you. In this case, if you remember one from last year, this is, well, originally this was written for the Feather Huzzah, but we're working with the Node MCU. But this is a app that will, you can set a predetermined route in Google Maps, basically just it uses the Google Maps API to determine what the traffic condition is between two specific points. In this case, the original author was from Ireland. He set it up to give him a heads up on his commute to work and which way and how long it was going to take him. And then we changed it to make this hilarious painting of the Bay Bridge give an indication of how long it was going to take for, especially if you're leaving the office at the end of the day, how long it was going to take for people who live over in Oakland to get across the bridge, which is usually a long time because it is a poor bridge that has way more traffic than it was ever designed to handle. In this case, we're still looking at the traffic in Ireland, so we might get some interesting results based on what time it is there, which is late now. And this should, so this doesn't use any of the services we were talking about before. This one connects directly to the Google Maps service, I believe over HTTP, and then we'll light up these NeoPixels in a specific color. There's one other thing that's really cool about the way this sketch runs, though. We'll look at that in a moment. Right now it's saying the traffic is still bad.
Well,
red traffic lights.
429, so that would make sense.
But in Ireland?
Oh, in Ireland. Yeah, that doesn't make a lot of sense.
No, not so much.
Anybody in the chat? I know there were some people from the UK somewhere.
Yeah.
So let us know how traffic is near you.
But anyhow, normally when you are, we're not even looking at the board here.
No,
now you can see the traffic lights. They're all red. We're all doomed. But anyhow, normally when you're, or I should say I say normally, most of the time when I'm working with these boards, you are actually putting in, say, your Wi-Fi details directly into your Arduino code. And that's fine, but it's not very dynamic if you have a project that you want to be extremely portable. And that's one of the things where this project really excels. Because if it's fully booted up right now, but if you hit the reset key twice on here, it goes into a mode where it is actually creating a web server on the microcontroller here, and then you connect to it with your telephone.
They might want to be able to see that.
They probably want to be able to see it.
I think so. Also, if you're interested in how to work with these NeoPixels, there was another stream about this on displays where you talked a little bit about this sort of setup.
We talked a little bit about displays. Anyhow, pull up my Wi-Fi details and waiting for the Wi-Fi network to populate on here. Keeps jumping around.
Ireland is not in the UK, but people had said that they were from London. So I figured that they might know what traffic was in the general area, but I appreciate you educating me. Thank you.
Oh, where are you, Wi-Fi network? Oh, it may have gone back to.
Okay, so somebody was talking about Z-Wave integration. I'm not sure what that is. Do you know what Z-Wave integration is?
I know that Z-Wave is a form of home automation stuff. Unfortunately, I am not terribly well versed in home automation things. So I don't really know how to advise on that. There we go. There's the Wi-Fi network we've been looking for. So it's Bay Display Conf. And then, so this is a web page that's actually being generated by the ESP8266, where we can set up the Wi-Fi network that it's going to connect to. Can also get some info from it, although most of that's just the hardware info. I guess if you're better at reading data sheets, then. But anyhow, then from here, you can tell it which Wi-Fi network you want it to connect to. Enter your password, and then it would connect to that network.
Very cool. And to answer another question posed by user 5 volts, there are like 70 different Wi-Fi networks because we're in San Francisco.
Yep.
So there are a lot of people using Wi-Fi for either their offices or for their own IoT things.
Also, the reason why the 2.4 gigahertz broadband network, or 2.4 gigahertz Wi-Fi band, is completely unusable in this city. Yeah. Because if you want to look at what that looks like in terms of cross traffic, that's 5 gigahertz.
Over here to this screen.
Yeah, that's what the 2.4 gigahertz Wi-Fi band looks like here in this office. It's a little busy, a little cluttered.
A few people using the internet here.
Yeah, although that's really referring to it. I should mention that the Wi-Fi antenna and the Wi-Fi chip on here is only 2.4 gigahertz. I believe the ESP32 also supports 5 gigahertz, but that's not really a big deal for this because the amount of data that this Wi-Fi antenna is going to be handling, yes, it'll be slowed down a little bit by all that cross traffic, but in general, like, it's tough to stream movies over 2.4 gigahertz from your laptop, but it is just fine for applications like this, even in really saturated network areas like here in San Francisco. Yeah, like I've never had any trouble with my garage door opener or anything like that, or any of the other devices I use with this. What's next? So we talked a little bit about the bridge traffic predictor there. What other things do we have to play with? Well, there's this guy that I was just talking about, and we should probably actually crack this case open so we can see what's inside.
Shall I look over here?
There's a bin of Allen wrenches.
I will unplug my mic for a second, or maybe I can get over here.
Yeah, you see it right out there on that box.
Got it.
And hopefully the right one is here for us. That's not the right one. You're not the right one.
It's always the last one. So start with the last one, and then you'll find it faster.
Yeah.
So you have this, I've seen that you have this at Maker Faire hanging off of the cameras at your live stream.
That's correct. Yeah.
Because this, it says official Make broadcast, and you'll see Tyler walking around with this above his head.
Oh, no, you
showing-
never see me walking around with that.
showing that this is going live and
Yeah.
that, you know.
I need my screwdriver set. I will be right back.
Well then, I will entertain you. I have notes about the ESP8266 because there's some really interesting things that are going on with this board. And I think that it's really cool because it has so many different options for being a $2 base board. So that little tiny thing can have up to 7 different peripherals, which if you don't understand what peripherals are, it's just kind of like things that it interfaces with. So up to 7 at once is a lot for a tiny little $2 board, which is why I think it's something that a lot of people choose for these applications. Both the low power mode and having multiple peripherals really makes it so that it's super versatile for whatever project you want to implement. Did we find it?
I think so. It's either this one or the one next to it. It's this one. Okay. Actually, we shouldn't necessarily go to the...
Another thing I should have mentioned, by the way, is that when we were talking about having a lot of noise in the area from having a lot of different Wi-Fi, maybe cellular noise, the ESP8266 has built-in filters to help take down unwanted noise as well. So it has some hardware built into it to help you eliminate some of those problems, which is why sometimes having a really busy area like this isn't as big of a problem when you're sending small packets of data and filtering out unwanted noise. So that's another little tidbit about the ESP8266 that is nice.
So we're going to take a look at the hardware running on this one first, and then we can look at some of the software that is driving it. And that is using if this and that, as I mentioned earlier, and Adafruit IO. All right, now the screws are out. And switch that, and we can lift the top off here. And so we have a couple different things going on here. We have, obviously here is our ESP8266, our Feather Huzzah, that I've created an access port here so we could use it for charging, things like that. That's one of the other really important things about the Feather that I love so much, is that it has well, the entire Feather ecosystem has this port right here for LiPo batteries, for single cell LiPos, and it has all the charging circuitry, so you can use you can charge it over USB. It'll run. You can then, when you're unplugged from the USB, it'll power off with the battery and work independently for quite a bit of time until the battery runs out, depending on what you're doing with it. Like this easily got me through, like this I believe is a 2000 or maybe a 1500 milliamp hour battery, and it definitely got me through a full broadcast day. And then you have it controlling these NeoPixels up here. And of course there's a little on-off switch down here that lets you power it off and still charge it even when the power switch is off. So I believe to make this work, I had it last running on a hotspot from my phone. So we'll get that fired up and then turn it on. And we get this one little green light here first. That's just it saying, hey, we're still booting and connecting to power. And then in a moment, we will take a look at some of the software. So it connected to Wi-Fi, and we got the the display going here. You see the neopixels lighting up here. And this is what's called edge-lit acrylic, where I've etched the logo in here, and lighting the acrylic from the bottom here makes the sign glow all pretty-like. You can even then close it back up, and that's how it is supposed to look normally. But enough of that. Let's take a look at the software.
And some people are saying that there's more than 7 external components that you can hook up, so just check the data sheet. The one I read said 7 external components as to use with it, but that may have just been the data sheet that I was reading, which isn't the same data sheet necessarily for the specific ones that we're using here. So it's always a good idea whenever you're checking out a board to just confirm those things with the specific data sheet first. That's always the one-stop shop when you're trying to pick out whatever component is right for your project. It's what I read religiously when I'm taking on a new project, which is why I went straight there to read all about it. And this one has a ton of information, which is great.
Yeah. All right. All right, so now we're taking a look at if T, or if this then that, depending on how you want to, what you want to refer to it as. Wait, am I on? Where do I find my stuff? Is it under services? No. There we go. And here we're really feeding data from these 3 triggers here. So it does a search for the hashtag MakerFaire and then sends data to the MakerFaire feed on Adafruit.io. And then there's, come on. Same thing for if you search for a tweet from DigiKey, then it does the same thing, or a tweet from Make, which I actually saw that this thing just did its little blinky light thing. Of course, because it's using if this and that, the data isn't in real time. You know, IFT is doing a lot of different things, so it tends to do the Twitter search maybe every 15 minutes or so. You can also force it to do it whenever you wanted. But I was doing this for a weekend at Maker Faire when people are going to be tweeting these things pretty much constantly the entire time. So I just wanted, you know, a big flashy sign to be lighting up and, you know, for people to be able to interact with it regularly. That was really the desired effect. I've seen some other projects that use a separate computer that does that handles all the Twitter searches and does that in real time and then sends it over using using MicroPython, and then that works well. But I wanted this to be completely self-contained because it had to live in a sign that was going to be on top of a camera.
Yeah.
Okay, so that's one part of the software. And then we go to Adafruit.io. And if we take a look at our feeds here, we're looking at the Maker Faire feed. And the data here is not terribly interesting because I'm just writing 1 to the feed when it matches one of those Twitter values. But we do get at least a timeline. I should switch the computer here.
Probably a good idea.
Apologies for that. So right now you get to your home on Adafruit.io. You create an account on here. Then you can see your different feeds here. or your different dashboards. Here what I'm looking at is feeds, and particularly the maker Faire feed. And the data graph is not very interesting, as I was saying, because it's all just constant 1. Because all that IFTTT trigger is doing is when it encounters one of the tweets that it's looking for, it writes 1 to this feed. But if you do look at your timeline here, you can see all the different instances of people hitting one of those, one or any of those triggers. And that's when you can start to see things getting exciting.
And you could possibly write not just a 1, but some other more analog value to change, like have it flow through colors or something like that.
Right. If I, for example, if I wanted a different interaction when somebody tweets with the hashtag MakerFaire versus somebody tweets to or from the Make account or the DigiKey account, I could create different values for those, and those can get written back to the code on the board that then create different interactions.
Awesome.
Yeah. So there's all kinds of fun stuff you can do with that. But and let's take a look at this thing again and see if we can force it to do a check so you can see the interaction. So let's switch to that camera, and we'll go back to if this then that. And I'm going to do a check now. This is on MakerFaire. It might not be too. Might not see anything on it yet, but
hey,
it does. Somebody tweeted MakerFaire recently.
Woohoo.
I wonder if it was one of you. So that's another example of the sort of thing you can create with if this and that. I mean, of course, this can be any number of different interactions based on Twitter. I mean, you can have a lamp in your house that turns on when somebody tweets a specific thing on Twitter, or any other internet sort of interactions or things like that. Mm-hmm. And then the last one is this is actually a project that I created after the last Skillbuilder, which is the one based on displays, and that was because it used this cute little 8x8 matrix display. And I loved how these things looked so much that I wanted to play around with them. So I made a little badge that I could change what it says from my telephone. And this is, of course, using Blink again. We can take a look at that. But first we should look, well, first let's get a look at this display because it is, I don't know, I can't get over this thing and how cool it looks.
They're saying that we should use the ESP8266 to automate changing of the camera view.
That would, I could, there is some sort of programming interface for the, so I'm doing the camera switching using the Blackmagic ATEM system. And I know it has some back-end code that you can use to program and automate this stuff. Or, I don't know, we could just have a bunch of solenoids pushing buttons. That'd be fun, too.
That would be pretty great.
That would make my life so much easier. Of course, you could probably also do this with other switching stuff, like if you use XSplit or anything like that. I think pretty much everything has an API now that you can use to interact with stuff. Anyhow, so that's what the display looks like, and that's the default message. It just says hello. But we take a look at the back here, we can see what's in here, which isn't a whole lot. Get this Velcro strap out of the way. And we just have our little LiPo battery. The ESP8266, the feather huzzah is just sitting there free floating. I've covered the back of it in electrical tape because we have all the exposed connections for the matrix display there. I want to protect them. But that's all there is in this guy. And of course, a little 3D printed enclosure. And a Velcro strap so I can, I don't know, put it attached to my backpack or something like that.
Yeah, I know they had, somebody here is mentioning that at DEF CON they had circuit board badges this year, so creating your own badge is very topical.
Yes. So not quite approaching DEF CON badge life, but a little bit of badge life.
But there was also, when I went to Maker Faire this year, there were a ton of people with their own made badges that were PCBs that had tons of cool interactions on them, and they were wearing them as a kind of icebreaker to talk to people about what they make, and it was really effective and super fun.
Yeah. So anyhow, I've also set this up so I can control it again using Blink because I love it so much.
Camera switching. There we go.
There we go. So what should we have this say? Who's been having a bunch of really good questions?
James has had some good ones recently.
Then we'll change.
There's so many though. There's no favoritism here.
We'll change this so it says James, and it needs one quick cycle, and there. Of course, we can also change the color. That's right. So now it should be in red. Maybe not. Maybe you can't see that quite as well as I would like to think you can. And you also have control over the scrolling speed, but I always find that changing this is a bit of a mistake. Okay, well, there it's a little slower, but this display also refreshes ridiculously fast, so now we can make it almost completely unreadable. Once it cycles through, maybe one more time to refresh it. Yep, there we go. Now we can't read it anymore. Let's back that off a little bit. Okay, well that is pretty much all I had as sort of a rough exploration into the ESP8266, how to work with it, how to program it, what you can do with it in your own individual projects, and a couple of different ideas based on some of the ideas I've had of how to build stuff with it. But there's so much you can do with this of just adding internet interactivity to your projects. That pretty much you can have it do almost anything you want. So I always like to see what other people are creating with it. I know that the Ruiz brothers over at Adafruit, they just created, it's a really simple one, but it's a 3D printed mailbox that when you get email in your Gmail account, little mailbox flag pops up. Tons of little interactions like that are what makes this device really possible, or make this device so much fun to work with.
Yeah, it seems really great, and it's so affordable for getting into for your first sort of IoT project, and it's really approachable. And there's a lot of projects out there, lots of documentation. There's some really great videos I've seen even on YouTube that you can go and look up to see what other people are doing with it. So it's a really wonderful little board.
Yeah. So that's going to do it for us today. Thank you so much for joining us. Of course, well, actually, no, I can't say goodbye just yet because we need to talk about the reason why we're talking about the ESP8266. And that has to do with the next project we're going to be building. I believe that's just in a little over 2 weeks. And that is the Becky Stern's social status tracker, which uses, I believe, this one, the Node MCU version of that 8266 board, and a bunch of 7-segment displays that gives you a up-to-date digital readout of your number of YouTube subscribers, I think Instagram followers, and a couple other metrics that you can plug into there and get cool stuff out of. You could probably also have it say your email inbox count if you really wanted to see that. I know I don't.
I want to see that less than I do.
Yeah, I open my email and I'm like, oh, there's still these thousands of messages I'll never read. I should probably just mark them all as read and get on with my life. And then promise I will never do that again. It'll happen again. But anyhow, we're going to be building that. I believe that is going to be scheduled for September 13th, back on our usual day of Thursday. And of course, and that project, once built, I will be taking it with me to Maker Faire, New York, and it will be on display at DigiKey's booth where you can see it and see the thing I built, and it'll look cool, and then you can subscribe to their YouTube channel and see the numbers go up, which is always a lot of fun. And of course, we need to once again thank DigiKey for making this series possible. If you missed them at the beginning, DigiKey is, well, they're the folks who make this series possible. They're an electronics distributor based here in the US. They have every single component that we talked about today, plus any single component that can go into your next electronics project, whether it's a Raspberry Pi, a microcontroller, or a package of resistors or capacitors, or whatever you need to build your next electronics project. They can get it to you, they have it in stock, and they ship it really fast. They always ship the same day that you place your order if they have it in stock, and depending on how quickly you ship it, sometimes it can be on your doorstep the next day. They're awesome to work with, and I cannot thank them enough. I can't thank you enough, Paloma, for joining me here today.
Thanks for inviting me.
It is
super fun.
So much more fun having this, doing these streams with a friend. Where can people learn more about what you're doing and what you're working on?
If you want to see the articles I've written in Make Magazine, you can search for me on my author profile on Make. I believe I have a Maker Share account, and you can check it out on there, some stuff that I've done. You could follow me on Twitter. I don't use it very often, but if I had one of those badges that he's making next week, you could see my subscriber count go up from that. And yeah, so if you're interested, feel free to reach out and ask me more questions about robotics and IoT. And I'd love to hear what you're working on and see what you come up with boards like this.
Excellent. And of course, I mentioned Maker Faire in New York that I will be going to, and you'll be able to see the project that we're building in 2 weeks there at DigiKey's booth. And if you are not familiar with it, that will be on the weekend of September 22nd and 23rd. That's in Queens at the New York Hall of Science, and you can get tickets now by going to makerfaire.com. And if you're in the New York area or the greater area, please come out. It's a great time. We would love to see you there. And if you see me there, please say hello, and because I always love to meet new people. So anyhow, that's going to do it for us today. Thank you so much for sticking around and watching. Kind of a brief stream today. We'll have more in our stream in just a few weeks when we build that project, and it'll be a whole lot of fun. Thank you so much for watching.
Now remember what I told you.
Yeah, don't make eye contact. He takes it as a personal challenge.
Hello? Pat?
Yes.
Can I get a,
He'll take a Raspberry Pi 3.
No pie for you.
Told you. Hey, but I did hear this new deli. I can go pick up the sandwiches.
Don't be held hostage by the board order. Go to digikey.com to find thousands of boards in stock, all ready for immediate shipment.